wait for green. And go. All right, we are going to solve absolute value equations. And we're going to effectively communicate our process. And I wish my pen was working to start that moment. Here we go. So we start by writing an equation that looks just like the original without absolute value on it. And we write an OR and say that we could also equal a negative 21 as a review from last year. And now we're solving two equations separately by doing inverse operations. Subtracting 6 from both sides gets me to a negative 27 and positive 15. And dividing by a negative 3 gets me to negative 5 and positive 9. And because good math students would check their work, we would plug back in to support that we have a positive 21. Nope, that was a positive 9 there as our end result. I feel good about that. We don't want to delete recording. Green light, I'm ready to go. Sorry. I need to minimize that to take on my blue ink, which I like better. And similar to problem number 1, we will remove our absolute value and set our equation equal to a positive 6 and negative 6. Again, performing inverse operations, we are going to subtract 4 from both sides, producing 2 and negative 10. Well, I forgot my OR in the middle, which is implied. And now inversing division by 2 is to multiply and have answers of 4 and negative 20, and supported with a check of the problem. Half of 4 is 2 plus 4 is 6, and a half of negative 20 is negative 10 plus 4 is also positive 6. Okay, and we're on our third equation to solve, which is slightly more tricky because of the two terms following the absolute value sign, which means we need to negate the quantity, and we have variables on both sides. So in one smooth step, I will collect terms and get a negative 5x and a positive 1. This needs an additional step of a distributed negative, and now collecting terms gets us to a positive x and a negative 1, I believe, when I collect correctly, and an answer of negative 1/5. And now I will check my work. So, that should look like a parenthesis. Uh-oh. Houston, we have a problem. Okay. Back to checking. And we now must put our parenthesis, our value of x, into both pieces. I had to scroll down for room. So this will go to 9 plus 2/5 is equal to 10 minus 3/5. Don't be afraid of fractions. They are your friend. 9 is really 45 over 5. So plus 2 is 47/5. And 10 is really 50 over 5. Minus 3 is 47/5. I'm feeling good about that answer. And now we're going to go check the other answer with a negative 1. So that's 9 minus 2 with a negative 1 in parentheses equals 10 plus 3 times the negative 1. That'll go to 9 plus 2 for 11. This will go to 10 minus 3 for 7. And anyone who's made it to Algebra 2 knows that's a false sentence. And as a result, only one solution exists at negative 1/5. A stunning example of why one should check their work. Peace.